Thanks, Marcus. We can all hear me okay? Fantastic. So great to be back here at XWorlds. First time in Melbourne. It's kind of fun. So yeah, as Mark said, my name is MacLaughlin. I'm a senior consulting engineer, implementation. Basically, I do a lot of weird bespoke workflows. I'm in a pre-sale sort of space. Someone will come up to the sales engineers. I'll be an escalation point. I might be a dev. I might be a subject matter expert. Across lots of different things here. Been in Jamf for about 8 years, based out of the Sydney office. Started in pro services, was kind of like a poor imitation of James Bond. I traveled all around the world, economy. The hire car was a Corolla, not an Aston Martin. And instead of a supermodel, it was an IT manager. But that had got me exposed to a lot of different organizations, lots of different verticals. So I've sort of dabbled around in that there. But yeah, so I have done presentations and webinars and things about certificates in the past. Most recently was one at JNUC last year where I was like Back to the Future of certificates. I lost my voice pretending to be Doc Brown, so this will be a bit better. But there was a lot of content in that there that I won't really go into. I will have links at the end of this of all these different resources. Some are Jamf links, some are Apple links, some are links you've never even heard about that might explain some of the reasons that you thought Apple just made a decision arbitrarily. And I'll be around all for the rest of the conference. Questions will be available if we got time in the end. I know we're kind of pushed for time, but come find me. I'm easy to spot. But yeah, so things are just going to be around deploying certificates to Apple devices. We're going to go high level on some stuff, but let's have a look at the agenda. So first we're going to do sort of just do a quick breakdown of what a certificate is. Again, for more like a high level type thing. We're going to then look at like what our goal is with certificates. So we're generally what the goals are I've had with the organizations, the customers coming to us, their goal with certificates, because they come in all shapes and sizes. And then I generally get reached out, as Mark's alluded to, customers got a cert that's not working. What's going on? So we'll sort of go through probably the two most common use cases I've seen for why a cert isn't working in an organization. And I've got some live demos pre-recorded because I didn't know what situation would be with networking and stuff like that there, of some different sort of scenarios of using certificates that will sort of be possibly relevant, possibly not in your organization. So let's sort of first break down like the certificate. Now, first we kind of need to tell them what type of certificate, because as I said, they come in all shapes and sizes. For the purpose of this presentation today, I'm going to be talking about what's referred to as identity certificates or client certificates. So that would be something like a .p12 or .pfx. It includes the private key and the certificate in there, sort of thing like that there. We will touch on other certificates and how they will still pertain to that, but the most common request I got around when I was looking for what content people wanted this was going to be around identity certificates. So if we expand out what an identity certificate contains, we have a root certificate. We have an intermediate certificate. We'll have our client certificate or leaf certificate. And we will have a private key. So let's sort of like go through and touch on what each of these sort of things refer to. So we'll start with our root certificate. Now, this is also known as the gold one. It is the root certificate's the first in the chain. It is the original, the OG. There's nothing that comes before it. All certificates come after it. You cannot issue any certificates without a root CA. All right? And if that gets compromised, take a long holiday. Turn the phone off, because that's going to be a fun time for anyone dealing with that. Next, we'll have our intermediate CA. Now, not every organization will have an intermediate CA. Some might just go straight from root to the leaf. It's sort of like in some cases it's optional, but if you do have it, it needs to be present in the chain. If you're using intermediate CAs, they need to be in the chain. The reason why a lot of organizations are using intermediate CAs, though, is it protects the root CA. So in the event that something happens to your intermediate CA and all subsequent certificates will be issued from that intermediate CA, you can then make a new one from your root CA, add it back into the chain, because you haven't compromised your root CA. All the trust keeps cascading down. So that's kind of why you would have that in there. And then finally, we've got our leaf certificate. I'm doing little animations just to try and make things a little fun. This would be known as like the leaf certificate, client certificate. This would be the certificate that the end user would see if they're trying to connect to 802.1x Wi-Fi or VPN. Or this would be the certificate you would see when you're going to an SSL website, like HTTPS, you click on the little padlock. This will be that certificate that matches that name. www.jamf.com, that would be the www.jamf. These sort of certificates can have different usages. The names of them are going to be defined by what's called a certificate signing request. And then the usages of that certificate are going to be defined by the CA that issued it. Usages could be something like client authentication, mail encryption, whatever you want to do. That's going to be determined by the CA, not by your CSR. Whoever's generating the certificate cannot say, hey, I want to use this for client authentication. You can just say, hey, my name is this. And then finally, we got our private key. Keep it private, please. It is private there. If you're thinking like using for leaf certificate, client certificate as authentication, think of the certificate as the username, the private key is the password. You don't share it out. You keep that as close to it there. It's also the first actually component that's generated when you are generating a certificate. A private key needs to exist first before you generate a CSR, because then you will point the CSR to that private key to then develop what the cryptographical mapping will be from a certificate that's issued back. In any situation that you are building a certificate and you have your private key, you keep that safe, because that's what's used to decrypt anything from the public keys. And if that's compromised, that becomes, again, book some holiday, take some leave, turn the phone off. So, and I mentioned like CSR, certificate signing request there. So we'll sort of talk a little bit about like what we're needing of those. So giving you an idea of a command there to generate a CSR. So I'm using the OpenSSL command. There are other command line tools out there. I'm very comfortable with OpenSSL, so I've used this. If we sort of break down what we're doing here, this is for generating a new CSR. So we can see the first argument there is a request. It's a new. That's easy enough there. We're including a new key with the encryption bit of 2048 bits. Nodes is actually no DES. And basically what this flag is saying that don't encrypt the private key. I did that for this argument so you can then see what it would look like. The key out, we're outputting it to a file, in which case this is called private.key, because I'm very creative. And the dash out is an out file of what the CSR is. So if we have a look at what that is when I run that command, we can then see what I'm going to be calling the certificate, what's going to be made into the CSR. So all of these things that are in the red box go into what's called the subject name of the certificate. Some people will get them confused between a common name and a subject name. A common name is a component of the subject. The subject is all inclusive. It will be common name, you can see towards the bottom, demo.xworld.com, organization, all of these have their own arguments against them. CN equals, O equals, L equals, C equals, refer to the different things here. This all information will then get spat out into a CSR. And this is what a certificate signing request looks like. We can see the certificate request at the beginning, certificate end, certificate request. Coughing into the microphone, I apologize. This is what would be generated off the private key and would be submitted to the certificate authority to then issue back a certificate. If we have a look at what the private key would look like, it's a bit longer. Again, this is not encrypted, but it doesn't have to be, as long as it's just kept secret and safe. This would remain always on the device when you're generating the CSR from. You do not need to move it around anywhere. To then have a look at what the output would be in terms of that chain, that trust, we can see inside, say, jamf.com, the root is Amazon's issuing CA. They then have their own intermediate CA, which is Amazon RSA 2048 M02. They're also not that creative with their namings. And then that then has issued a wildcard.jamf.com certificate. That is the lease certificate, that's the client certificate. So wherever this is hosted, there is a private key that corresponds to wildcard.jamf.com that is living on those web servers. They are protected, they don't leave those servers. Then the corresponding public keys and all that stuff there kind of marries up to that. And I won't go too much into that because we don't have a huge amount of time. But that's sort of an very quick, rough breakdown of what an identity certificate would contain. So now that we have an idea of what that looks like, let's have a look at what we would potentially use certificates for. So we can use them to replace passwords for authenticating something like 802.1x Wi-Fi. We could use them to replace something to access cloud resources. Or maybe we want to look at actually trying to replace some methodology to logging into the Mac. And I will touch on that later, if I've seen some of you pick up on that. But the first thing the first challenge we face is, how do we get the certificate onto the device? is it generate from that, how are we sending these instructions in a way that is supportable, secure, and doesn't make us lose all of our free time. So 3 methods that I've sort of seen out in the wild of how we've pushed certificates out to organizations. I've seen one organization that they emailed their certificate to every user. Yeah. If you are doing this, you already know it's very manual. It's also extremely insecure, and it does not scale at all. Another method that is still used out there is the end user will be directed to go to some form of certificate portal. They might then authenticate, fill out some information, then they'll be prompted to download. That is better than emailing, but it's reliant on the end user to do the right thing, which we're all admins here. Relying on the end user to do the right thing means we have jobs. But yeah, so that also has its own caveats and problems. And the end user experience actually on Apple devices is not great because a profile still then needs to be generated, download, then they need to follow the steps of doing the installation. It doesn't install automatically, it's not trusted necessarily automatically. So finally we have the third method, which is pushing out via MDM. And that's the method we're going to talk about a bit here now. The reason why we'll focus on MDM is the recommended way is for not necessarily all these reasons. There are more reasons, but these are the sort of the most 4 common. It's definitely quicker. Anyone who's pushed out a configuration profile using APNS and MDM, it's a lot quicker than you going and doing that clicking, or an end user doing all that stuff there. So the speed of it already is a win. You can automate these deliveries. So a large amount of MDM vendors will include this as part of an enrollment profile or enrollment steps, or when a device matches certain criteria, then you push out the certificate. So the admin doesn't need to be involved. You can schedule this and then they're there. So there's our scalability working as well. And I will touch on scalability. Be automatically trusted. So certificates that are sort of downloaded and then manually installed aren't always necessarily trusted, but certificates pushed out by MDM are trusted by default. And I will talk about that a bit as well, but that is Apple's own methodology. It's coming through a trusted channel, i.e. MDM, therefore we will add trust to it. I'll do, and the scalability, as I mentioned, you can then also, and a lot of MDM vendors support this, you can leverage what's called like profile variables or variables inside the config profile. So you could have one profile to cover all of your devices. There should be little asterisks on the scalability. That will come down to your MDM, your CA, and how many certificates you're trying to generate at once. I have seen one organization where they went live on 10,000 devices in a day without telling their cert team. Yeah, who were sitting in the next room. Also, unbeknownst to us, going live on a Windows platform rollout that was also using the same CA. Anyway, so here I've got an example using Jamf Pro, because I am from Jamf, using the SCEP payload in a config profile. We can see I'm leveraging profile variables, so that $full name is I'm reading information about the device, so I only need one profile to then inject all that information rather than one profile per organization. I can then also look at doing subject alternative names. So you might want to use the full name as like maybe something the end user would be seeing, and that's the friendly name. But actually what's authenticating in the back end might be going off a SAM account name or some RGB ID number that isn't familiar to the end user. So you will put that maybe as an alternative name. So it will be using that if it doesn't match the subject name, the common name, to then authenticate to your services. As an option there. So I'll take this profile and I'm going to push it out to my test device. Easy. Done. Pushing out MDM. It's got its corresponding private key. No problem whatsoever. No. So this is something I come across very often. Certificate is not trusted. But I push this out by MDM. And Apple's own documentation says certificate trust. A certificate is automatically full trust if it is, and the second one there, automatically installed from a supported MDM solution. So Apple, I've done the right thing. I pushed out my certificate from MDM. Why is it not trusted? All these links and everything will be at the end as well. So if we go back and look at the certificate, the reason it's showing as untrusted is we are missing the full chain. So we can see at the top there, I got to click here. This is issued by a certificate authority called Outer Rim NPS CA. Threw this together very quickly. That is nowhere on the system, and that is an internal CA. So the operating system itself doesn't know where this issuer was and cannot trust or validate it at all because it's not on the system. Because that, the chain is missing, so the certificate is no longer trusted. So let's grab that intermediate CA, or that CA, and push it out to the device. So now we can see now down the bottom, Outer Rim NPS CA is installed. We have a slightly different error message now. Instead of saying that the Daniel MacLaughlin certificate is not trusted, it's now saying that the Outer Rim NPS CA is not trusted. So let's have a look at that one. We click and select that. Now it's saying that one's not trusted. We can see at the top there that it is an intermediate certificate authority. It's not gold. Or I said the root certificate's the gold certificate. Nothing comes after the gold certificate. So what we need to do is, we don't know where this was issued from, because that's not showing in that same sort of field that we saw for the Daniel MacLaughlin certificate. So I need to double click on it inside keychain, and I can now see all of the information that relates to that certificate. And here I can see that there is a Outer Rim root CA that issued this Outer Rim NPS CA, this intermediate CA. If I look back at that, that needed to be on the machine. So I go get that root certificate, I push that out by MDM. Now it's down there at the bottom, and it's gold. Certificate's valid, certificate is trusted. The one thing that's about that trust that I mentioned in an Apple's document, and it doesn't touch on it too clearly, the little blue plus that you see on the root certificate down the bottom, that's Apple flagging this as trusted because it came from MDM. Right? So not all certificates are root certificates, but root certificates are certificates. So that's one thing that I've seen trip people up so often, is they've just pushed out the client certificate, but the intermediate or the chain is broken, the chain is missing. That, no matter what you've done, will not show as trusted when you just put that through an automated method. Now, I apologize for the poor formatting, because I could not, and props to the CAs out there, I could not force this to be the case, to force a certificate to be the next error message I've seen. But this is a very different error, but it also looks very similar. My certificate is showing as non-standards compliant. Now, if I go back, the certificate chain is still there. Daniel MacLaughlin, the NPS, the root CA, that's all there. This message is not saying it's not trusted, it's saying it's not standards compliant. Reading is hard. We just see red messages and we think it's not trusted, and we go back and what the hell's going on. So we need to understand what this means by non-standards compliant. Back in November 2019, so hence why it's getting a little rarer that I'm seeing this message, but it is still around, because people were setting certificates for valid for 5 years. In November 2019, Apple released the updated KB article from iOS 13 and macOS 10.15 and above will now be conforming to these compliance requirements. A lot of text in there, links again will be at the bottom, but the one key thing that we're running into, and why we look at the certificate again, is we'll notice that my certificate's expiration is listed for 27th of March 2029, which is much longer than the 825 days that we're allowed to have for TLS certificates. Now, this 825 days was not something that Apple decided. It was something that the CAB forum collectively met with external and internal entities about what is going to be the new guidelines for certificates. Other sort of things that they mentioned, SHA-1 should not be used. Security bits for private keys should be 2048 bits and higher. All these sort of things are listed in there, but the one that I always ended up seeing a lot was they had an old legacy CA that was pushing out certificates with a lifespan of 5 years. Then they get this certificate as non-standards compliant. Not Apple choosing to do that, a wider thing, but it did mean that we had to start revisiting and checking what the expiration dates were in a lot of certs. There is a different compliancy requirement for third-party SSL certificates. So certificates you might get for hosting a third-party website. They're valid for up to 398 days. Again, a decision made by the CAB forum in conjunction with Microsoft, Google, Amazon, Apple, every big player was sitting there. So you could go and request a third-party SSL certificate for 10 years, but it will actually be valid for 1, and you'll just get a renewal code to go back and get a new certificate every year. Alrighty, some live stuff. So the first sort of example I'm going to be showing you is using a certificate to access some cloud resources. So what I'm going to do is I'm going to go and open Safari. I've already pushed out the certificate you've seen in the keychain. It's the exact same demo machine. I'm going to go to my Microsoft portal, just going to go to my account at Microsoft.com. And I have an option here to use the certificate to log in. So I click this. I'm then prompted for a certificate out of my keychain. I go continue, and I am logged in. No password needed. An identity certificate was taking place of that. Nice and easy. Now, let's say, however, though, that I wanted to, that was an Azure ADFS login. What about if I wanted to have that at the login screen of a Mac? So before I hit play, we can kind of notice there is no account on this Mac for User Connect. And so with Jamf Connect login explicitly, 2.22.0 beta 2, a lot of 2s, we now have the ability to access certain certificates at the login window. So I log in, and I apologize, this was me handy-camming it myself. iMovie stability is kind of making it like a rocking, the low tide. But that same message, the screen will flash, because it's still in beta, we'll get to that there, but it only found one valid certificate. So then it's past the IDP stage, and now I'm prompted for passwords because of macOS security. You cannot have a completely passwordless setup on the macOS operating system. Because it's a new account, I have to set the password twice, set and verify. It's going to go through and create the account. I did speed up the no Siri, no location, things like that there, so we're going to see that in a second. When I log out and then log back in, I will just be prompted to verify my password. So it will still get past the IDP stage using the certificate, but then using the local macOS password in that security posture. I wouldn't say that you would look at using a certificate to replace the login screen. It would be more of an additional multi-factor. So the user still needs to be involved with some sort of password there and the verify there. But kind of useful. Again, some caveats about what certificate you can use. Apple are very, what's a nice word? Apple are very Apple on the security guidelines, especially at the login window and accessing certificates or any items that are in a keychain, because that's where the security, that's where all these things are. There's a lot of lines we have to sort of walk to make sure that we're not compromising the security of the end user, the device, and our own product. The last one is probably the most common that I'm seeing, and that would be connecting to an 802.1x wireless network. So I've taken my exact same profile, the SCEP profile, but I'm adding a network payload into the same profile. The SSID is called the Force, because I'm a Star Wars nerd. Picking my security type is Enterprise 802.1x. The EAP type is TLS. That's generally the most common I've seen for certificate-based. And I'm associating the identity certificate, the SCEP certificate, with it there. I'm then flagging what the radius issued certificate is. In this case, it's the NPS certificate. You can upload the certificate manually, or you can specify the name if you know it. You can see the machine that I'm on is in range of the Force network. And I can scope this out to my device, go save, and then I will go and open the system settings on this machine, and we'll see it automatically switch over. This is not sped up, so I apologize. Yep, there we go. Switched over to the Force network. If I click on the details pane of that, and then go to 802.1x, we can see it's authenticated by EAP TLS. So it's using that certificate to authenticate to that wireless network. No user involvement, because I have the whole chain and everything present. No errors, no prompts, just seamless 802.1x network auth. That's basically it. I told you it'd be quick. I've made a collection, a whole heap of links. Some will be referenced also in my previous JNUC talk. I've included the recordings that I've set that there. The shortened link and the QR code go to the exact same spot. Just some people like to type, some people like to QR code. Up to you. There is no rickrolling, I promise. How are we doing on time? Cool. If there's questions, by all means. Yes, James.
How did you get a cat in your Wi-Fi name?
How did I get a cat in my Wi-Fi name? Okay, that's a good one. The Unicode, it's very interesting when I go to other OSs. Sometimes it comes up as the yellow cat and then a black square. When I was in an apartment building, there was Wi-Fi networks galore, and my wife kept complaining that she couldn't find our Wi-Fi network. So making it an emoji put it to the top of the list. And yeah, we have 2 black cats now, so it made sense to sort of doing that there. It's not that hard to do. You can actually go and find, depending on what Wi-Fi vendor you use, what your router stuff. Most of them support it now. The only one I've seen where it doesn't show the emoji, it will show the weird Unicode, was Raspberry Pi. Raspberry Pi did not like it at all. But yeah, that's how I got the emoji on the Wi-Fi. That's the takeaway from that whole presentation. Bart, do you have a question? Favorite chapter of the OpenSSL man page? The thing I use the most is S-Client. If you ever go man OpenSSL, it's a novel. There is a lot of that REQ one is one of, I think, about 30 subcommands you can use OpenSSL. What frustrates me a little bit is OpenSSL on macOS isn't true OpenSSL. So there's some issues with it handling TLS 1.3 certificates and checking all that kind of stuff. But it does enough for what I need to do. S-Client's probably the one I use the most, where I need to validate what certificate is being presented on a URL that I'm trying to go to versus what certificate I'm being told is being used on that URL. But yeah, can't pick favorites really. Does anyone have any other questions? Jules, you can interrupt Marcus. It's encouraged. So the Jamf Unlock does require Jamf Connect, and it requires the iOS device that is being used to be managed as well. So the BOIOD for it there. We aren't getting a huge amount of people trying to use Jamf Unlock because generally the personal devices aren't being managed, and that's what they want to use for it. And Jamf Unlock was sort of used, for those people who aren't aware, is for an extension onto Jamf Connect, where you can use biometric as like a Bluetooth-based smart card, for want of a better word. So you can use your biometrics on your phone to unlock, then instead of doing a password for that there. It's fun to use, but in practical applications, we've had a lot of resistance from customers because their end users have personal phones that are not wanting to get managed. And the management is around app config and all stuff like that. James?
Can you do that management with account-driven user and ROM? So does that type of management suffice for Jamf Unlock?
I believe the current build of Jamf Unlock requires app config, which you can do in the account-driven. It's, I think, down to how Apple will let us host it. And how it will pair with identity and some other things like that there. Just because you can doesn't mean we should, is probably the best way of doing things. That should be on a t-shirt somewhere.
I ask because that's a much nicer way of managing a personal device.
I agree, yeah. But you'll still have potential some feedback or resistance of why should I be enrolling my own phone into something that because there's still that paranoia. IT will read my messages, they'll read my emails on that. What a benefit am I get there for me just typing in my password? So I think we're kind of on that there. I don't know how we're doing on time. We're good on time. I will be around as well. Come find me in the Jamf booth. I'm not hard to spot, I don't think. So if you want to have a bit more of a one-on-one or different things around there, by all means. But with that, thank you very much.